Hi everyone, welcome to mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 1, which is a pure mathematics 1 for February-March 2023, and the code is 9709/12. Okay, so let's move on to question number 1. So for question number 1, a line has equation y equals to 3x minus 2k, and the curve has equation y equals to x squared minus kx plus 2, where k is a constant. Show that the line and the curve meet for all values of k. Okay, so when we are showing the curve is meeting the line, right, that means that is the intersection points. Right, now we have to solve the simultaneous equations. So I will let the first y equals to second y. So therefore I will start with 3x minus 2k equals to x squared minus kx plus 2. Okay, so from here I will move all the terms to the right side so that you are getting a quadratic equation. So I will get x squared minus kx plus 2. By moving the 3x to the right side, it will be negative 3x. Then the minus 2k becomes plus 2k, then equals to 0. Okay, so from here, I will rearrange so that it will be in the general form of quadratic equation. Then first term will be x squared. Now from here, I will group the term with the x. Okay, so these two terms will be grouped together, and at the same time, I will factorize the minus x. Then I will be getting k plus 3. And the k2 and 2k will be grouped together. That will be my constant. Okay, so from here I will write down the coefficients for x squared, x, and the constants. So the coefficient for x squared is denoted by a. The coefficient for x is denoted by b. That means this is negative of the bracket. And then my constant is going to be 2 plus 2k. Okay, so from here, to show that the line and curve meet for all values of k, I need to consider the discriminant, which is a b squared minus 4ac. So now your b is negative k plus 3. Then now you square it. Minus 4a is 1, c is 2 plus 2k. Okay, so from here, when I square the negative of k plus 3, the negative square, it will be positive. Then I just need to square the k plus 3. That means I will do the expansion for k plus 3. Then you will be getting k squared plus 6k plus 9, because I'm going to use this formula, a plus b squared equals to a squared plus 2ab plus b squared. Okay, after that, the minus 4 times 1 is minus 4. This will be multiplied to the bracket. Then I will get minus 8 minus 8k. Then from here, I will simplify it. Then you'll be getting k squared. 6k minus 8k, it will be negative 2k. Then plus 9 minus 8 is plus 1. Okay, so from here, I'm getting another quadratic function, which is k squared minus 2k plus 1. And this can be simplified into k minus 1 squared. Okay, and now we know that the line and curve meets for all values of k. All values of k means that the k is real number. And then we know that for this square of k minus 1, it is always at least 0 for all k values. Okay, so when the b squared minus 4ac greater than 0 means that you will have 2 roots. And then when it is equal to 0, then you'll be getting 1 root. So from here, the roots here is basically the x coordinate, right? So from here, we know that the intersection between the line and the curve will be having real and equal roots here, right, for any k. So the line and the curve has the line and the curve have I will write the line and curve the intersection. Okay, here I will write, okay, I better write real and real, okay, it could be real and equal or real roots. Okay, so this is the meaning of greater or equals to 0, means that you will have same x or different x, right? And they are defined. Therefore, the line and curve intersect or meet for all k values. Okay, the line and the curve meet for all k values. Alright, so that is how we solve the question number 1 here. Okay, now for question number 2, a function f is defined by fx equals to x squared minus 2x plus 5. For x is real number, for real number of x, a sequence of transformations is applied in the following order to the graph y equals to fx to give the graph y equals to gx. So this is your original graph. And then now you have to go through these 3 transformations. Now, the first is stretch parallel to the x-axis with scale factor of half. And the second is reflection in the y-axis. Then the third is stretch parallel to the y-axis with scale factor 3. Okay, now find gx, giving your answer in the form ax squared plus bx plus c, where a, b, c are constants. Right, so for the first one, okay, so for first one, stretch parallel to x-axis with scale factor half. So it means that your x here, right, because of the scale factor half, that means your x here will become 2x, right? So I will get y equals to, instead of x squared, you change to 2x squared, then minus 2 of 2x plus 5. This is for the first transformation, which is a stretch parallel to x-axis with scale factor half. Now for the second transformation, which is a reflection in the y-axis. So for your information, let's say this is a line, okay, this is a graph. So when you reflect it in the y-axis, that means it will be here. Alright, so which means all your x, right, will be positive x. So that's the meaning of this reflection in the y-axis, which means now my x will be changed to minus x. Okay, so which means my y is negative 2x squared, because your x changed to negative x, then minus 2 of 2 or negative 2x. I will just direct write negative 2x, then plus 5. Okay, so now I do the expansion or simplification. So square of minus 2x, it will be 4x squared. Then minus 2 times minus 2x, it will be plus 4x, followed by plus 5. So this is the function after the second transformation. Now the third is stretch parallel to y-axis with scale factor 3. Okay, so now for the third one, it's going to be y equals to, okay, so you times the 3 to the whole function now, okay, because of stretch parallel to y-axis with scale factor 3. So it will be 3 of the previous function. So I will get 4x squared plus 4x plus 5. Then at last you'll be getting 12x squared plus 12x plus 15. Okay, therefore my gx, so my gx is going to be 12x squared plus 12x plus 15. Okay, that's the solution of this question. Now, for the next question, a curve has equation y equals to 1 over 60 times square of 3x plus 1, and the point is moving along the curve. Find the x coordinates of the point on the curve at which the x and y coordinates are increasing at the same rate. So whenever you see rates, means that is d over dt. Okay, because the x and y coordinates are increasing at the same rates, means dx equals to dt. And it will be positive for both because of the increasing. Alright, so now what I need to do is from here, okay, you need to find the x coordinate. What is the x? So from here I can get dy dx, because you are given dx dt and dy dt. So now I will get dy dx. Now for the differentiation, I'm going to use this formula, d over dx fx to the power of n. Okay, so when you differentiate, you see here, this squared is for 3x plus 1. Okay, the squared is for 3x plus 1, it's not for 1 over 60. So what you need to do is, just for the square of 3x plus 1, you apply this formula, which is the power rule, bring down the n, and then rewrite the fx, the power becomes n minus 1 and differentiate the fx becomes f prime x. So of course the 1 over 60 is a constant, then I have to keep the constant because of the second formula here. So it will be c differentiate the function of x, right? So now here I will keep the 1 over 60, and then this squared will be brought down based on the power rule. Then I will be getting 2 bracket 3x plus 1. The degree must always be minus 1. So 2 minus 1 is 1. After that, you differentiate the bracket. So when you differentiate 3x plus 1 is basically 3. Okay, so from here, now I can simplify my values. 2 times 3 will be 6. So this 6 will be cancelled off, or will be cancelled off with 1 over 60 over here. That means the denominator is 1 over 10. Right, so I will be getting 1 over 10 of 3x plus 1 degree 1. So this is my dy over dx. Now, I will write dy over dt is dy over dx times dx over dt. So now my dy dt is same as dx dt. So I will replace my dy dt by dx dt. Okay, then here 1 over 10 bracket 3x plus 1, then multiply with dx dt. Since I have dx dt on left and right side, then I can cancel off. So when I cancel off means that left hand side is 1. Okay, then I will get 1 over 10, or 1 equals to 1 over 10 of 3x plus 1. So the 10, I times 10 to the whole equation. Then I will get 10 equals to 3x plus 1. Then from here, I will be getting the x values. So by moving the 1 to the left side, I will be getting 9 equals to 3x. Therefore, your x is going to be 3. So that's the x coordinate of the point on the curve when dx dt equals to dy dt. Okay, now the next question is number 4. The circumference round the trunk of a large tree is measured and found to be 5 meters. After 1 year, the circumference is measured again and found to be 5.02 meters. Now, given that the circumferences at yearly intervals form an arithmetic progression. So, arithmetic progression. Find the circumference 20 years after the first measurement. So this is our first measurement. That means that is our first term, 5. Okay, and then followed by 5.02. So from here, I know that my first term A is 5. My D is 5.02 minus 5, which is going to be 0.02. D is a common difference. And now you need to find, after 20 years, what is the measurement? That means you need to find T20. Okay, so, alright. So now, for your information, okay, it is not T20. Look at the question carefully. 20 years after the first measurement, which means, okay, this is the first measurement. Let's say this is the first measurement, A. Right? So here is going to be, I will write, this is T1. That will be better. So T1 is the first term, T2 second term, and so on. Now it's measured after 20 years after the first measurement. That means here is going to be 20. Okay, so the 20 is after first, which means you need to find this is T21. Okay, so it is not T20. Alright, please take note on this. So P21 is how much? Alright, so now T21 formula is A plus 20D. So I will get 5 plus 20 times 0.02, and then you will be getting 5.40 meters. Right, that is the solution for 4A. Now, B, given instead the circumferences at yearly intervals form a geometric progression. Find the circumference 20 years after after the first measurement. That means now you need to find T21. Okay, so I'm getting geometric progression right now. So copy back the first term 5, second term 5.02 from the first part. So here 5, 5.02, and so on. And so on. Then now you need to find what is your T21. So again, from this geometric progression, you'll be getting A is 5. The common difference is, common ratio R is second term divided by first term. Okay, then which is 5.02 divided by 5, and you will be getting 1.004. And now we need to count T21. T21 for geometric progression is AR power 20, because the formula is Tn equals to AR power n minus 1 for geometric progression. Okay, so now your A is 5, your R is 1.004, then power 20. And at last, you'll be getting 5.42. So that is the solution for the part B. Okay, now for question number 5. Point A with coordinates 7, 12, and B lie on a circle with center -2 and 5. This is a center. Now, the line AB has equation y equals to -2x plus 26. Find the coordinates of B. Okay, so from here, we know that A and B will be on the circle. Let's say this is the A, 7, 12. Okay, and then this is the B. Alright, so then with coordinates -2. Okay, so my graph, my labeling is wrong because the my A with 7, 12 and B is unknown. Okay, and line AB is y equals to -2x plus 26, which means the line having a negative gradient, so your B should be somewhere here, right? So this is your A, so that it will be having a negative gradient for the line AB. Then this is 7, 12, and then it's mentioned that your center is at -2, 5. Okay, -2, 5, which means my A is not there. Then the center is -12. Let's say here is the center. This is -2, 5. Okay, maybe your A is over here because the x coordinate is positive, and then the x coordinate for the points for the center is negative. So let's say this is a graph, just a rough idea. So this is your A, 7, 12. Okay, so from here we have found a line. I mean, this is the line. Maybe this is a circle like that. Right? So now what I need to do is I need to find what is my R first. Okay, so my R is actually the distance between the center and the points A. So if you still remember the distance formula, distance, let's say your A is x1, y1, B is x2, y2. So your AB is going to be square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so now I will use this formula to count the radius, which means it will be square root of 7 minus -2 squared plus 12 minus 5 squared. Okay, so then from here you will get the first one is going to be 9 squared, and then 12 minus 5 is 7, so I will get 7 squared. Now when you take the square root of the sum of this, it will be square root of 130. Okay, so now I need to find the points B, but I notice that my points B is actually the intersection points between the line, this is the line which is given, and also the circle. So which means now my next step is going to get the equation of the circle. So equation of circle. Now basically for equation of circle, it will be, let's say the center. Okay, so the center is with coordinates x1, y1. Okay, and then the radius r. So equation of circle is basically x minus x1 squared plus y minus y1 squared, then equals to x squared, equals to r squared. This is the equation of circle. So provided the x1 and y1 are the coordinates of the of the center. So from here, my center is given -2 and 5. Therefore, this is going to be x minus -2 squared plus y minus 5 squared, then equals to radius squared. So square root of 130 squared. So now I will get x plus 2 squared equal plus y minus 5 squared equals to 130. That is my equation of the circle. Okay, so I will let this be my first equation, and this straight line will be my second equation. So y equals to negative 2x plus 26 will be my second equation. Right, so now I will substitute second equation into first equation in order to get the intersection points. So at the same time, my first equation has square of x plus 2, so I will do expansion for this. Then you will be getting x squared plus 4x plus 4, then plus, replace the y, okay, y minus 5 squared, the y there, by minus 2x plus 26. So I will get negative 2x plus 26, then minus 5 squared equals to 130. Okay, so for this bracket, right, I will simplify. 26 minus 5 is basically 21. So I will just direct write 21 squared. And then I have to expand again the squared here, right? Have to do the expansion. Then I will get x squared plus 4x plus 4. Now, plus square of negative 2x will be 4x squared. And then negative 2x times 21, then times another 2. You will get negative 84x plus square of 21 is basically 441. Then now, this 130 will be moved to the left-hand side. So becomes negative 130 equals to 0. Okay, so then from here, I need to solve this quadratic equation. So now, x squared plus 4x squared, it will be 5x squared. And then for 4x minus 84x, you will get negative 80x. So it will be negative 80x. And then the rest of the constants, you just simplify. So this is plus 4. Alright, plus 4 plus 441 minus 130. Then you will get plus 315 equals to 0. Then from here, I will divide the whole equation by 5. Then you will get x squared minus 16x plus 63 equals to 0. Okay, once you get this, then you need to factorize this. Okay, now when I factorize this, I will be getting two linear factors, x minus 9 and x minus 7 equals to 0. So it means that your x either 9 or x equals to 7. But then, now, look at the question here, or look at the diagram over here. So from the diagram, I know that A is the intersection point between the line AB and the circle, and so goes to the B. So that's why you are getting 2x here. Okay, because one for A, one for B. Now, your A x coordinate is 7. That means now your B must be x equals to 9. Alright, so when x equals to 7, that is for points A. Therefore, for points B, the x must be 9. So now, from the question, we need to get the coordinates of points B. That means you need to find the y coordinate as well. So now you can just substitute into the line AB, okay, to get the y coordinates of the B. So I will write y equals to negative 2x plus 26. Then I'll replace the x by 9 to get the y coordinate. Then I will get here 9 plus 26. So minus 2 times 9 is 18. Minus 18 plus 26 is basically 8. Therefore, my B will have coordinates 9 and 8. That's the solution for the points B. Now for question 6, in the expansion of this, right, degree 7 of x over a plus a over x squared is given that the coefficient for x degree 4 over the coefficient for x is 3. Now find the possible values. Look at the values here of the constant a. Means that you are expected to give more than one a. Okay, now first of all, I will do the expansion for this, but I won't get the full expansion because our concern is the coefficient of x degree 4 and also coefficient for x. Alright, so I will just use the expansion formula. This is same as summation 7r. R start from 0 until 7. First term, which is x over a. So first term to the degree of r. Second term to the degree of 7 minus r. Okay, then now I will split the x and the r. Oh, sorry, x and the a. Okay, so r from 0 to 7, it will be 7r here. Then bring in the r to both numerator and denominators. Then I will get x degree r, then a power negative r, because the a is at the bottom. Alright. Then here I will get a to the power of 7 minus r. Then the x squared at the bottom means that x degree negative 2. So I will get x degree negative 2, then bracket to the power of 7 minus r. Okay, whole term negative, with power of 7 minus r. Then from here, I can simplify the degrees of a and r. Alright, so it will be summation r from 0 to 7, then 7r. Now, when you look at here, this is x degree r, here is the x. So we have a formula, okay, especially for the second term. So if a to the power of m, then another degree n outside, basically this is a to the power of m times n. Okay, so from here I will write x degree r, and at the same time I have to combine both x. See? Now, if this is multiplication, a times n, a power n times a power n, okay, same base, it will be a to the power of m plus n. So now we have to add the degree, which means I will be getting plus, then this you have to expand. So it will be negative 2 bracket 7 minus r. Okay, and same goes to the a. So since this is a multiplication of two same base, I will add the degree. So it becomes minus r plus 7 minus r. Then now I will simplify all my degrees first before I proceed to next step. So I will get x. Now, when you look at here, okay, this is negative 14. Then here is going to be positive 2r. So the positive 2r together with the r here becomes 3r, right? So I will write it is 3 degree of 3r minus 14. Then a, now open the bracket, minus r will be minus 2r. So I will get minus 2r plus 7. Alright, so now I can just use this form to get the coefficient for x degree 4 and also x. So if I need to get x degree 4, the term with x degree 4, which means my x degree 4 must same as the x degree 3r minus 14. Okay, so it will be x to the power of 3r minus 14. So when I compare, since they are having the same base, we can just ignore the base and compare the powers now. So which means 4 is 3r minus 14. Then now, move this minus 14 to the left side. I will get 3r equals to 18. Therefore, your r is 6. Okay, then hence I will get coefficient for x degree 4. This coefficient for x degree 4 happens when the r equals to 6. So substitute this 6 into this, all these terms without the summation. So I will get 7c6. Okay, then since we are interested to get the coefficient, means that you can just ignore the x. So I will just write the a directly and replace the r by 6. Then plus 7 over here, which means this is going to be 7c6 a to the power of negative 12 plus 7. So you will get negative 5. And then you will be getting 7a to the power of negative 5. So that's the coefficient for x degree 4. And now, next step is to get coefficient for x. It's the same method. So if it is x degree 1, that means, alright, so I will just repeat this step, but change this 4 to 1. So here I will get x degree 1 equals to x degree 3r minus 14, which means now 1 is 3r minus 14. Therefore, by moving the minus 14 to the left side, I will get 3r is 15. Hence, the r is going to be 5. Okay, and then now my coefficient of x. So I have to replace my r by 5 in these two terms. So I will get 7c5. So here 7c5 a to the power negative 2 bracket 5 plus 7. So which means you will be getting, okay, 7C5 is basically 21. Then A, now negative 2 times 5 is negative 10. Negative 10 plus 7 is going to be negative 3. Okay, so these are my two coefficients. And now I'm going to substitute these two coefficients into the given form here. So the division of both coefficients equals to 3. So now coefficient of x degree 4 divided by coefficient of x equals to 3. So now just substitute. So the coefficient for x degree 4 is 7a to the power negative 5. So 7a negative 5 over 21a to the power negative 3 equals to 3. So now I will get the 7 and 21 can be simplified into 1 over 3. Okay, and now you need to get 2a values. That means now I will be getting this 3, this 1 over 3, right, move up. So I will get 8. Okay, now for your for your information, when you have division of two same base, let's say a power m over a power n, it will be minus of the degrees. So now at the same time, I will times the whole equation by 3 here. Okay, this is going to be 1 over 3. Then now I will be getting a to the power negative 5 minus negative 3. Then this once you times 3, right, or probably I just write times 3. Then left hand side, the coefficient 1 over 3 becomes 1. Then the right hand side becomes 9. Then from here, I will get a to the power negative 5 plus 3, which is negative 2. Okay, so a power negative 2 is basically 1 over a squared, which is 9. So I will just move up the a squared and move down the 9. So I will get a squared is 1 over 9. Therefore, my a is going to be plus minus square root of 1 over 9, which means you'll be getting plus minus 1 over 3. So therefore, when you refer to the question here, it's mentioned possible values of a. You are expected to give more than one a value. Okay, and hence here I'm getting 2a values. Okay, now let's move on to question 7a. By first obtaining a quadratic equation in cos theta, solve the equation tangent theta sine theta is 1 for theta between 0 and 360 degrees. So the hints already given, alright, the hints is given. You have to change to quadratic equation in terms of cos theta. So what we need to do is just use a definition for tangent theta. Tangent theta is basically sine theta over cos theta. So firstly, I will copy the question, then change the tangent theta into sine theta over cos theta. Otherwise, you won't be able to get the cos theta there. So here sine theta equals to 1. Then sine theta times sine theta, it will be sine squared theta in the numerator. So I will be getting sine squared theta over cos theta equals to 1. Okay, now we have an identity. So sine squared theta plus cos squared theta is 1. Okay, so from here, in the question, you are given that forming the quadratic equation in cos theta, which means we need to eliminate the sine squared. So I have to move the cos squared theta to the other side, which means my sine squared theta is 1 minus cos squared theta right now. So now, by replacing the sine squared theta, you will be getting 1 minus cos squared theta over cos theta equals to 1. So in order to get quadratic equation, okay, the cos theta you move to the right side. So it means that I will be getting 1 minus cos squared theta is cos theta. And then I will just move all the terms to the right side because I want to get positive cos squared theta. So then you will be getting cos squared theta plus cos theta. The 1 to the right side, it will be minus 1. Okay, so from here, I am not able to factorize this quadratic equation. This is the quadratic equation in terms of cos theta. I'm not able to factorize this. Therefore, I'm going to use the quadratic formula. Before quadratic formula, let me write down the coefficients for the terms first. So the a is a coefficient for the term with the square, which means it's 1. The b is a coefficient for cos theta, which is 1. The c is going to be minus 1. Okay, now for your information, quadratic formula, which is ax squared plus bx plus c equals to 0, then your x is going to be minus b plus minus square root of b squared minus 4ac over 2a. Okay, that is the reason I have written down the a, b, c values. So now, for your information, if you are given ax squared, you will be getting x. But then now I'm getting cos squared theta, which means my x will be replaced by cos theta. So then I will get cos theta equals to minus b, right? So then the b is going to be 1. So I will get minus 1 plus minus square root of b squared minus 4ac, then over 2a. Then from here, you will get minus 1 plus minus. So this is going to be square root 5 over 2. And now I have to get two values, right? The first one is counted using minus, the minus square root 5, because here plus minus. And the second one is going to be plus square root 5. So I will be getting 0.6180 and the other one negative 1.618. Now, we know that cos theta maximum is 1, minimum is minus 1, which means the next one, the second one, is no solution. Okay, it does not define for negative more than, the cos theta must be between negative 1 and 1. So this is outside the range, right? So now my cos theta is 0.6180. And now when you refer back to the interval here, it is between 0 and 360 degrees. Now, cos theta is positive when the angle is in the first and last quadrant. So now I have to get the first angle here. Now my theta is going to be 51.8 degrees. Okay, you just get the inverse cos 0.6180. So here I get 51.8, and my second angle is going to be here, right? And for your information, this is also 51.8, the lower angle. So which means to get the major angle here, I'm going to use 360 degrees minus 51.8. Alright, then you will be getting 51.8 degrees and 308.2 degrees. So that's the solution of the question. Okay, so we already solved the question, first part. Now, B, show that tangent theta minus sine theta equal tangent theta over sine theta minus sine theta over tangent theta equivalent to tangent theta sine theta. So when you need to prove the identity, I will always start with the complicated part. Okay, so the complicated parts will be the left hand side, because at least you have two terms here, then we can simplify. No, I will start with left hand side, which is a tangent theta over sine theta, then minus sine theta over tangent theta. So when you need to simplify this, the easiest way is get the same denominator. Means that you combine the sine theta and tangent theta. So now I combine both. So when I combine both means that my numerator is like cross multiplication. Okay, so now I will be getting tangent theta times tangent theta is tangent squared theta. Then minus sine theta times sine theta, it will be sine squared theta. Okay, but when you refer to the question here, I need tangent theta sine theta. So what I need to do is the tangent squared itself, I will be changing it to sine squared theta over cos squared theta. I will change everything to sine and cos first before I change back to tangent for the final answer. So here minus sine squared theta, then divided by sine theta times tangent theta. So here sine theta times tangent theta. Right? So now I will get, now for the numerator, I will get the same denominator first. Means that here I times cos squared theta over cos squared theta. Okay, because I need to simplify. So I will get sine squared theta, then minus, okay, or I will just do it step by step. So the sine squared times cos squared, I will just rewrite as sine squared theta cos squared theta over cos squared theta. Then divided by, okay, this is going to be sine squared theta over cos theta. Okay, then now since the numerator here you have both terms with denominator of cos squared theta, then I will combine both. So when I combine both, I will get cos squared theta. Then now I will combine the numerator. Okay, so when you divide by sine squared over cos theta, I can just change to times, but then I have to interchange my numerator and denominator when I change the divide here into times. Okay, so now for the first function or first rational function, I notice that the sine squared theta is in common. Therefore, I will factorize the sine squared theta. And then you will get 1 minus cos squared theta, then over cos squared theta, and then times with cos theta over sine squared theta. Okay, so from here I can cancel off some of the terms, which means the cos theta will be cancelled off, but then the first term denominator still have degree 1, and then the sine squared theta will be cancelled off. Okay, now you will be getting 1 minus cos squared theta over cos theta. Alright, so now this 1 minus cos squared theta is basically sine squared theta, then over cos theta, and now I will split it into two terms. It will be sine theta over cos theta times another sine theta, because I have sine squared theta, and then the sine theta over cos theta is basically our tangent theta together with the sine theta. So with this I have proven the identity. Okay, so now let's move on to the next question, number 8. Now the diagram shows triangle ABC in which angle B is right angle. So here is the right angle. Now the length AB is 8 centimeters. So here is 8 centimeters. And then the length BC is 4. So it's given 4 here. Now the points D on AB such that AD is 5. So here is the 5. And therefore the DB will be 3 because total AB is, the length of AB is 8. Now the sector DAC is part of the circle with center D. Okay, DAC. So this is the sector. Okay, and then the center is SD. Now find the perimeter of the shaded region. So basically the perimeter of shaded region is the arc length of the sector DAC plus the AC. Alright, so before I get this, I need to know what is my angle of ADC. So basically, angle of ADC can be found by getting the angle BDC first, because you are given the right angle triangle. Okay, then only I use pi minus the green angle, that will be my blue angle. Okay, so now when you look at the triangle BDC, alright, so this angle BDC, okay, angle BDC, now this 4 is the opposite side of the angle, and then the 3 is the adjacent side of the angle. So you have opposite and adjacent, that means this is tangent. So I'm going to write tangent angle BDC is 4 over 3. Okay, so then from here, my angle BDC is inverse tangent 4 over 3. You will get 0.9273 radians. Now, therefore, my angle ADC is pi minus 0.9273. Therefore, you will be getting 2.2143 radians. Okay, so once you have found the angle ADC, then we can find the arc length of the sector ADC, which is the AC here, the sector here. Okay, so now my arc length of sector ADC is going to be theta r. So now my theta is this is my theta, is the angle ADC. So which means it will be 2.2143, and my r, based on the diagram, since the D is a center, that means the r is 5. Then you will be getting 11.0715. That's the arc length. Now my next step is to get the AC. So when you need to get the AC, okay, let's look at the whole triangle ABC. Okay, now the BC is 4, the AB is 8, so I will get the AC by using Pythagoras theorem. So which means now my AC is square root of AB squared plus BC squared. Which means this is going to be square root of 8 squared plus 4 squared. Then you will get square root of 80. Okay, so now I have found the AC and also the arc length. Therefore, perimeter of the shaded region is just to add up both. Equals to 11.0715 plus square root of 80. So now, when I round up the answer equal to 3 significant figures, it will be 20.0 centimeter. Okay, so that's the solution of this question. Now next, find the area of the shaded region. So area of shaded region is basically area of sector ADC, whole sector, minus area of triangle ADC. Okay, so now I will get area of sector, or I will just direct solve. That will be better. Area of the shaded region equals to area of sector ADC minus area of triangle ADC, right? ADC. So now area of sector ADC formula is half r squared theta. Okay, this is half r squared theta. So I will write half. The r is basically 5. Okay, this is a sector 5. Then the theta is 2.2143. So r squared, so 5 squared times 2.2143 minus area of triangle. Okay, for your information, if let's say this is the area of this is a triangle, and you know this is the theta, the angle bounded by two sides will be theta, then the area is going to be half AB sine theta. Okay, so now when we look at the diagram, we know that D is the center of the radius, D is the center of the sector, which means your DC is radius as well. This is 5, here is 5, and then the angle bounded by these two sides will be 2.2143. So I will be using the half AB sine theta to solve the area of the triangle right now. So it will be half 5 sine 2.2143. So now when you calculate the next value, which is the second value, make sure you change the mode of the calculator to radians, right? Because the angle is in radians. So the first value, I will get 27.67875, and then the second value is going to be 9.99998. Now this is the working, that's why I give more decimal places or more significant figures. But my final answer, I just round up to 3 significant figures. That will be the solution of part B. Okay, now for question 9, the function f is given by negative 3x squared plus 2, whereby the x is less equals to minus 1. State the range of f. So the range is basically the y value, right? So now I will count what is my f negative 1 first, because your x inclusive minus 1. So I will get negative 3 bracket negative 1 square plus 2. Then you will be getting -1. Okay, so for information, when you sketch this graph, right, it is like this, -3x². Now you just move up 2 units. Okay, so when I move up 2 units, I know that when the x is less equals to -1, right here, less equals to -1, here is a -1, this is 0. This is 0, this is -1. That means I know that my y value is going to be -1. Alright, so means that my x axis is somewhere here. This is going to be -1. So this is my diagram. Here is -1. Right? Therefore, according to this, then you will be getting the range. Range is the possible y values. Right? So my graph is not correct. This is going to be 0. Okay, then you plus. It's supposed to be like this. It's supposed to be like this. Then you plus 1, plus 2. Means it is somewhere like this. Alright. So my graph is not really accurate. So it should be somewhere like this. Okay, so roughly like this. Alright. So then I will get my y value. I know that my graph will be having a maximum point. Alright. At 0 and 2. Okay, therefore, since your x is less than -1, which means it will be somewhere this. Okay, this is your -1. The y is -1, the x is -1. So this point is -1, -1. Since your x is less than, that means going down. Therefore, all the y will be going down, which means my range of f, my fx is less equals to -1. Okay, so this should be the proper explanation for that. Now, find an expression for f inverse. So whenever you get the f inverse, you have to let the function be y first. Then we will get the x as a subject. So y equals to the function itself, -3x² plus 2. Then now I need to get the x as a subject. So I will move this -3x² to the left-hand side in order to get positive. So 3x² equals to the y will be moved to right side. So 2 minus y. Then now x² move down the 3. So I will get 2 minus y divided by 3. And hence, my x is going to be plus minus square root of the function. Okay, now my f inverse. Now, for the f inverse, you cannot choose both plus or minus sign. That's why it depends on your range. So since your range is less equals to -1, means that I will be choosing negative instead of plus. Then square root of the y will be replaced by x. And this is my inverse function for f. Okay, now the function g is defined by gx is -x² minus 1, whereby the x also less equals to -1. Solve the equation f(gx), this is a composite function, minus g(fx) plus 8 equals to 0. Okay, so from here I will rewrite my fx first. My fx I copied from previous part, -3x² plus 2. So -3x² plus 2, and then my gx is -x² minus 1. So to get fgx, right, so fgx is f of gx. So you replace the x in your fx now, okay, by x² minus 1. So all the x must be replaced. So I will get -3 bracket minus x² minus 1, then squared plus 2. Okay, so you can leave it in this form or you can simplify it, because later I need to substitute into here. Probably I will just simplify now. Alright, so that means this is going to be -3. Then I will do expansion for this quadratic. You'll be getting x² plus 2x² plus 1, then plus another 2 outside. Then you'll be getting -3x. Sorry, I miss out. Okay, square of x² is going to be degree 4. Right, square of x². So here is going to be -3x cubed, 3x degree 4 minus 6x². Then minus 3 times 1 is -3. Minus 3 plus 2, it will be -1. Okay, now for the gfx. So gfx is going to be g of fx. So now my fx I will replace. My fx is negative 3x squared plus 2. So now, when you need to get this composite function, your x in the g will be replaced by negative 3x squared plus 2. Therefore, I will get negative 3x squared plus 2, then another squared, then minus 1. Okay, then from here, the negative remain. Square of minus 3x squared plus 2, you will be getting 9x degree 4 minus 12x squared plus 4, then minus 1. Then I will be getting minus 9x degree 4. The minus is plus 12x squared. So minus times 4 is minus 4. Together with the minus 1, it becomes minus 5. Okay, so now I will substitute into this equation. Fgx minus gfx, then plus 8 equals to 0. Then I will be getting negative 3x degree 4 minus 6x squared minus 1, okay, from the first composite function, then minus all these terms. So minus negative 9x degree 4 plus 12x squared, then minus 5 plus 8 equals to 0. So now I open the brackets, you will get negative 3x degree 4 minus 6x squared minus 1. The minus is a plus for the first term inside the bracket. Then minus times plus 12x squared, it will be negative 12x squared. Minus times minus 5 is plus 5. Then plus 8 equals to 0. Okay, so now simplify the terms with the x degree 4. So 9x degree 4 minus 3x degree 4, you'll be getting 6x degree 4. Then the one with the squared, negative 6x squared minus 12x squared, it will be negative 18x squared. Now 5 plus 8 is basically 13. 13 minus 1, you get plus 12 equals to 0. So this whole equation can be divided by 6. Then you will get x degree 4 minus 3x squared plus 2 equals to 0. And now I will factorize this into 2 factors. But then since you have x degree 4 and x squared, I will be getting x squared minus 2 and x squared minus 1 equals to 0. Okay, then now when products of two terms equals to 0 means that either the first term equals to 0 or second term equals to 0. So now x squared equals to 2, which means your x will be plus minus square root 2. Now for the next one, x squared minus 1 equals to 0 means x squared equals to 1. Therefore your x will be plus minus 1. Okay, so now let's look at the question. Because we know that gx is defined when the x is less equals to minus 1. And then same goes to the fx. Fx is defined for x less equals to minus 1. Which means now, for both composite functions, fgx and gfx, the x must be less equals to minus 1. So now, since x less equals to minus 1, that means now we cannot consider the positive x. Therefore, your x is going to be negative square root 2 and also negative 1. Okay, so these are the two solutions for this question. Okay, now for question 10. At the point 4 minus 1 on a curve, the gradient of the curve is negative 3 over 2. Is given dy dx is this expression. Show k value. For your information, gradient of the curve is referring to dy over dx. Alright, so now I will replace this dy dx by negative 3 over 2 when the x is 4. So now dy over dx is x to the power of negative half plus k. So when dy dx is negative 3 over 2, my x is going to be 4. So this is 4 to the power of negative half, then plus k. Alright, so 4 to the power of negative half is basically 1 over square root 4. So then I will get negative 3 over 2 equals to half plus k. Therefore, my k is going to be negative 3 over 2 minus half, which is negative 2. So we have shown this k value. Okay, now find the equation of the curve. So now I have to rewrite my dy dx. So now my dy dx is x to the power of negative half plus k. Now my k is negative 2, so minus 2 now. Then I need to integrate. So my y is going to be integration of x to the power of negative half, then minus 2 dx. So when we integrate, right, so integrate x degree and dx, we need to add 1 degree to the existing degree, then over the new degree. And this formula is valid when n is not minus 1. Okay, therefore, by applying this formula, I'm getting x degree negative half plus 1 is half. Then divided by half, minus the 2 becomes 2x because initially x degree is 0, then plus c. Now, the first term, x degree half divided by half. So 1 divided by half is going to be 2. So I will get 2 square root x minus 2x plus c equals to my y. But we cannot allow the answer in terms of c. The c can be found by replacing the coordinates of the point on the curve, which is 4 and minus 1. So now at 4 minus 1, that means the x is 4 and the y is minus 1. So now I will get minus 1 equals to 2 square root 4 minus 2 times 4 plus c. Okay, so then here is going to be square root 4 is 2. 2 times 2 is 4. Then minus 8 plus c equals to minus 1. So right hand side is going to be minus 4 plus c. Then now my c is going to be minus 1 plus 4, which is 3. Okay, therefore my equation of the curve, just replace the c value. So my y equals to 2 square root x minus 2x plus 3. So that is my equation of the curve. Right, now C, find the coordinates of the stationary points. Stationary points happens when dy dx equals to 0. So just now you were given the dy dx. Okay, so I will just copy this and let it be 0. So 0 equals to x to the power of negative half minus 2. And now, this x to the power of negative half, I will change to 1 over square root x. Then now, 1 over square root x is going to be 2. So the square root x move up. So square root x move up, the 2 move down. It will be half. Then now, to solve this, I will square both sides. So now, square both sides. Therefore, my x is going to be 1 over 4. Okay, because when you look at the question, stationary points means 1 point. Then I will just need to get 1x. Once you have found the x, to get the y coordinate, just substitute back into your curve equation. So y equals to 2 square root x minus 2x plus 3. And now the x equals to 1 over 4. So my y is 2 square root 1 over 4 minus 2 bracket 1 over 4 plus 3. Then square root 1 over 4 is half. So 2 times half minus 2 times 1 over 4 is basically 1 over 2, then plus 3. Then I will get 1 minus half plus 3. And you will be getting 7 over 2. Therefore, the stationary point with coordinates of 1 over 4 and 7 over 2. Okay, so that's the solution for this part C. Now D, determine the nature of the stationary point. So the nature here means either maximum or minimum. Means that we need to differentiate second time. So now I will rewrite my dy dx, that is x degree negative half minus 2. So now d squared y over dx squared. Bring down the power negative half. Then rewrite the x. The power always minus 1. So minus half minus 1 is negative 3 over 2. And then now, from the stationary points, the x is 1 over 4 in the previous part. So now, I will substitute my x by, my x by stationary points, my x by 1 over 4. Okay? So now, when I replace it by positive 1 over 4, my d squared y over dx squared is, okay, this is basically negative half bracket 1 over x to the power of 3, then here square root, right? That is the meaning of this expression. So I will get negative half, then 1 over cube root, not to say cube root, it is square root of 1 over 4 to the power of 3. Okay, so from here I'm getting a negative value because the denominator here is always positive after the square root. Then because of the first term is negative, then I will just write less than 0. So when it is less than 0, I will be getting a maximum point. That means, right, the stationary point is basically a maximum point. So 1 over 4, 7 over 2. So 1 over 4, 7 over 2 is a maximum point. Alright, so that's the solution for D. Now, for question 11, the diagram shows the curve with equation x equals to y squared plus 1 and the points A, B are on the curve. Okay. Find the equation of the line AB. So to get the equation of line AB, very simple. Just use y minus y1 equals to m bracket x minus x1. So firstly, I need to get the m first. So now A with coordinates 5, 2, B with coordinates 2 and minus 1. So now my MAB, the gradients of AB. Now, the gradients of AB is found by y2 minus y1 over x2 minus x1. Okay, so now I will write 2 minus my MAB, okay, my y, okay, not the x. So I will use the A as the x1, y1. So 2 minus minus 1 over 5 minus 2, that is my y2 minus y1 over x2 minus x1. Then numerator is 3, denominator is 3, therefore it is 1 here. Now, my equation of line AB, equation of the line AB is going to be y minus y1 equals to m bracket x minus x1. So I will use the point of A. So it will be y minus 2 equals to, my m is 1, so x minus 5. That means my y is 1 times x minus 5 just remain. And then the minus 2 on the left hand side just move to the right side, becomes plus 2. Then from here, you will get y equals to x minus 3. So that's the solution. Okay. Now, B, find the volume of revolution when the region between the curve and the line AB is rotated 360 degrees about the y-axis. Okay, so when about the y-axis means that your region will towards the y-axis. So from here, in order to get the volume of the shaded region, it will be volume of this, right? I have to find this whole volume minus the second volume. So which means it is a volume 2 minus volume 1. That will be the volume of the shaded region. Now, my volume 1, okay, I count my volume 1 first. My volume 1 is basically you rotate the region below the graph, right? Therefore, I have to use the graph equation. So for your information, my volume 1 is pi x squared dy because of y-axis. So now, the y values, look at the points here. This is x, this is y. So my y is minus 1. Here is x, here is y. That means the y is 2. Means that now you integrate from minus 1 to 2. Okay, so here minus 1 to 2. And then the curve equation. Okay, where is the... Now, for your information, this V2 is the region. Okay, sorry, I'm finding V1 now. I'm finding V1. So V1 is the rotation of the region below the graph. So now I have to copy my graph equation. X equals to y squared plus 1. Okay, x equals to y squared plus 1. Alright. So now it will be it will be, okay, x equals to y squared plus 1. So now this is a x squared. That means I have to square this, right? So it will be pi integrates from minus 1 to 2. I square the y squared plus 1 because that is my x only. So now it will be pi integrate from minus 1 to 2. I need to expand first because the y squared. So when I square the y squared plus 1, you'll be getting y degree 4 plus 2y squared plus 1 dy. And now when you do integration, is the first term is going to be y degree 5 over 5. Second term is 2y cubed over 3. Third term is going to be just y. Then now you replace the limits. Replace the y by 2 first, then minus when it is minus 1. So I will get 2 degree 5 over 5 plus 2 over 3 times 2 degree 3 plus 2. All of this you minus when the y is minus 1. So minus 1 degree 5 over 5 plus 2 over 3 times minus 1 degree 3 plus minus 1. Okay, so from here, you will be getting the first one is going to be 206 over 15. And then minus the second one, the second bracket is going to be plus 28 over 15. Alright, then you will be getting 78 over 5 pi. That is our V1. Okay, now for the V2, the V2 is basically the rotation of the region below this AB. Means that now I have to integrate the AB, right? I mean the x squared dy again, but then the x is from the line AB. So now my line AB is y equals to x minus 3. So our line AB, y equals to x minus 3. That means now I need to get my x. My x is going to be y plus 3. So now my V2 is integrate is pi integrate x, let's say this is 2 lah. Okay, x2 squared dy. And then again the limits will be the same. So the limits will be from minus 1 to 2 as well. So here is going to be minus 1 to 2. Then now I will get pi integrate minus 1 to 2. Now I need to square this x. Means that I square the y plus 3. For this, you can either do expansion or I will just use the formula. Ax plus b to the power of n dx is going to be ax plus b to the power of n plus 1 over n plus 1, and then differentiate ax plus b is a plus c, right? Because of indefinite integral, provided n is not minus 1. Otherwise, you can just do expansion and integrate term by term. So now I'm going to apply this formula. This is going to be pi, then y plus 3, instead of degree 2 now becomes degree 3, over 3, differentiate y plus 3 is 1. Then limits from minus 1 to 2. So now here, I will factorize the over 3 and combine with the pi. I will get pi over 3. And then now replace the y by 2 first. So I will get 5 degree 3 minus, when I replace the y by minus 1, is going to be 3 minus 1, which is 2 cubed. Okay, then now here you will get 117 over 3 pi, which is our 39 pi. Okay, so now my volume of the shaded region is going to be V2 minus V1. So it's going to be V2 minus V1. Then V2 is 39 pi. My V1 is 78 over 5 pi. Okay, at last you will be getting 23.4 pi. So that is the volume of the shaded region. Okay, so we also come to the end of the video already. Alright, thanks for watching. Please subscribe to my channel and stay tuned for more upcoming videos. Thank you. Bye.